Number 4, we're going to go through a process of factoring something out, and there's going to be some code words. Now, first of all, this might be kind of difficult to look at because there's an x to the 4th, even though there are 3 terms. So what I want to remind you is sometimes they try to trick us. Don't let that happen. What if they would have said that this function was actually x squared minus 12x minus 13? Then, if I would have approached that in letter A, that meant that if I was factoring that, I would have done x minus 13 times x plus 1. And I would have been done. But I see that if I do it this way, I only produce x squared when I multiply the first things. And the trick, if there is a trick, is that all I need to do is put a square on each of the x's, and now I can produce the 4th degree polynomial that I was talking about. Now, there are some code words that you have to be aware of. So first of all, the first code word is saying, when you see this thing that says rationals, is that number 1, you don't want to have any I values, so no I, no imaginary. And second, you don't want to have any square roots. So as I look at my factorization, what I know is I see that this stuff over here that I just factored, whoopsie, this is not what I wanted. So anyways, the stuff that I just factored had no square roots and no i's in it, so I'm good to go. Then, well, I gotta move that thing still. Sorry. Let me just put this back where I want it. There we go. And then, the second thing that we're looking at in part B is to say, do something, but this time, instead of doing it over the rationals, what I want you to do is I want you to do it over the reals. And so what the word reals means is that you can't have any i's involved. And the crazy thing is, if I look at that first parentheses, I see that I have 2 things with a minus in between them. Now, it would have been really cool if it would have said something like x squared minus 9, because then I could have done x plus 3, x minus 3. But the trick is here, if there's a trick, is that if I look at that parentheses, that's really the difference of 2 squares, but in an unconventional way. So I could really write it as x plus the square root of 13 times x minus the square root of 13, because when I multiply those 2 things, of course, what I see is that I get back the parentheses that I just highlighted in yellow, x squared minus 13. And that's because the square root of 13 times the square root of 13 is 13. And then I just leave the second parentheses because they didn't want me to do anything with that because it has a plus in there. And then the last thing says to factor completely. And what I'll notice about factoring completely is there's only really one thing left I can do, and that's with the last parentheses. Now, if this last parentheses would have been x squared minus 1, what I would have done is I would have rewritten that parentheses as x plus 1 and x minus 1, because that would have been the difference of 2 squares. But because it's the sum of 2 squares, what happens instead is I really have x plus 1i and x minus 1i. And this second parentheses that was highlighted in green turns out to be this. The first 2 parentheses stay the same, and this is being factored out completely. And what I want to show you is what would have happened with a different number, because the number 1 is sometimes kind of annoying, like it's easy to work with. So let me just show you off to the side here what would have happened if you would have had something just a little bit different. So first of all, for example, if I had x squared minus 81, that would have been x plus 9 times x minus 9. But if I have x squared plus 81, that turns out to be x plus 9i times x minus 9i. And you can check that out to see. One's called the difference of 2 squares and one's called the sum of 2 squares. And then the last thing that I'm being asked is to say, hey, what are all the solutions then if I have those factors? And all you really do is look inside the parentheses and say, hey, what makes all of these parentheses 0? So from the first parentheses, I see that I have negative square root of 13 that would work. The second one is positive root 13. Third one is negative I. Fourth one is positive I. Being the math studs that you are, you're going to write down plus or minus the square root of 13 and plus or minus I. And those are the solutions based on the factors that we got. Now this last problem that we're going to do is kind of involved. We're not going to do number 6 together. You guys can work that on your own if you want to and then check it out. We're just going to do number 5. What I want you to notice in number 5, again, is that they tell us that the highest power is 4. That means in the end I should find 4 zeros. And they give me, in this particular problem, that one of my zeros is 2 plus 3i. Knowing that it comes in conjugate pairs, I also have a solution of 2 minus 3i. Why is that important? That's important because if I write those down, x equals 2 plus 3i and x equals 2 minus 3i, I can change those into factors by rewriting them equal to 0, or in other words, saying that x minus 2 minus 3i equals 0 and x minus 2 plus 3i equals 0. Then, if I write them as factors, I will see that I have x minus 2, oops, sorry, a little bit ahead of myself here, x minus 2 minus 3i times x minus 2 plus 3i as two factors. And what I'm going to do now is I'm going to actually FOIL this out. So let's look at the first term, x, and multiply that by each piece. So x times x is x squared, x times negative 2 is negative 2x, x times 3i is positive 3ix. Then I'll go to the second one, which is the negative 2. Negative 2 times x is negative 2x, negative 2 times negative 2 is positive 4. Negative 2 times 3i is negative 6i. And then my last one, I'm going to take that negative 3i and multiply it by things. So negative 3i times x is negative 3ix. Negative 3i times negative 2 is positive 6i. And then negative 3i times positive 3i is negative 9i squared. Now as I try to simplify this stuff, I notice that there's some things that will cancel out. So I see that there's a positive 3ix and negative 3ix. Those are gone. I also notice that there's a negative 6i and, whoopsie, let me undo that and use a different color, sorry. I notice that there is a negative 6i and a positive 6i. Those disappear. And then what I see is that as I look in here, I have an x squared, so I'm just going to write that down. So I have x squared. And then my negative 2x and negative 2x give me negative 4x. And then I also notice that I see negative 9i squared, which we know since I squared is negative 1, that's actually a positive 9. And I also see a positive 4. So 9 and 4 makes 13. So I have 13. And what this is saying is with those two solutions, that I know that this polynomial divides evenly into the one that they gave me up above, which was the x to the 4th polynomial. So now I'm going to divide that into it and see what's left over. So I write down a division symbol, and I write down the original function, x to the 4th minus, minus 4x cubed plus 12x squared plus 4x minus 13. And I'm going to do the long division that we learned earlier. So I asked myself, what do I multiply x squared by in order to turn it into an x to the 4th? And the answer is that I would have to multiply that by x squared. So I multiply by x squared. X squared times x squared is x4. X squared times minus 4x is minus 4x3. And x squared times 13 is 13x squared. And I subtract off all of that stuff. And when I subtract off all of that stuff, what I end up with is the x4's canceling out, the x3's canceling out. I get 12x squared minus 13x squared, which is negative 1x squared. I bring down the 4x, And I also bring down the minus 13. And then I'm trying to turn that gray x squared into negative 1x squared, and obviously that means I have to multiply by negative 1. So I do that and I get negative 1x squared plus 4x minus 13. And when I subtract all that stuff off, I have a remainder of 0. What does that mean? That means that the stuff that I see over here, this x squared minus 1, also divides in evenly. So I have the x squared minus 4x plus 13 that did, and that's how I had my two imaginary numbers. But that x squared minus 1 is going to be a quadratic that produces two more answers. So I asked myself, how do I find the answers? Well, I could factor that, and if I factor that, I can turn the x squared over here, minus 1, this stuff that we found out goes in evenly, into x plus 1, x minus 1. Set that equal to 0, and I find out that my other two solutions are negative 1 and 1. So I have four solutions, two of which are real, negative 1 and 1, and two of which were imaginary, which were the x was equal to 2 plus 3i and 2 minus 3i. So if I were going to consolidate and write them all as one unit, I would tell you that my solutions are x equals plus or minus 1 and 2 plus or minus 3i.